Good morning, afternoon, or evening, everyone, and thank you very much for joining us to this webinar on setting the standard, a new approach to energy efficiency. My name is Charles Van Tier. I am Director of the Real Estate Standard at GRESB, and I also serve as the Secretary to the Real Estate Standard Committee, or RESC, who is the committee within the GRESB Foundation responsible for maintaining and developing the GRESB Real Estate Standard over time. It's a pleasure to be your host today, and we're going to be talking about energy efficiency in the real estate sector with a particular focus on the alignment between GRESB and ASHRAE through GRESB's recent incorporation of ASHRAE 100 values in its methodology. And to help us properly understand this topic, we've got with us two experts in the field, Parag Cameron-Rastogi, Directors of Real Asset Analytics at GRESB, and Jamie Kono, Research Engineer at the Pacific Northwest National Laboratory, or PNNL, who's been directly involved in the very development of the ASHRAE 100 standard. Jamie, ladies first, could you please briefly introduce yourself to our audience?
Sure. Yeah, hello everyone. So I'm Jamie. It's great to be here. I work doing building energy efficiency research in the US, and also for the past 6 years have been involved with the ASHRAE 100 committee, which is really what's bringing me here today. Gotten really really deep into how the targets and just generally how that establishing efficiency metrics for existing buildings comes about. So great to be here.
Thank you, Jamie, and thanks for your time. Parag, may I ask you the same question?
Sure, yeah. So as Charles mentioned, I'm Director of Real Asset Analytics at GRESB, which means really anything to do with data and building science at GRESB. So I support Charles in the Real Estate Standards Committee, providing technical background, technical support for standards development and product development. And I have been a member of ASHRAE for over 10 years now. Recently got my pin, so not wearing it today. I haven't been involved with the development of the ASHRAE 100 standard, but I am a member of the committee for the climate zone standard, which we'll also refer to later.
Thank you both. Thank you so much in advance for your time and insights. I hope you're all looking forward to hearing from them on this topic today. I certainly do. So in terms of program for today, this is what we have for you. So I will kick off with a short high-level overview of where the topic of energy efficiency sits within the direction, the strategic direction of the GRESB standards, which is led by the GRESB Foundation. Parag will then follow with some insight into the technical development process of this topic at GRESB, followed finally by Jamie, who will speak a bit about ASHRAE as a standard setting organization and their engineering-based approach to defining energy efficiency. We have then selected a few questions recurringly asked by our members on this topic, and we'll of course, after that, open the floor to you afterwards by directly answering questions raised through the chat window. And before we start, just a couple words on housekeeping. This webinar is being recorded, and we will follow up to all participants with a direct link to the recording shortly after the end of this webinar. As mentioned, please feel free to use the chat function to send you any questions that you have. We'll do our best to address them live, but we certainly follow up afterwards to the ones that we have not had the chance to answer. And finally, if you do have a question that you forgot to raise here, always feel free to drop us a note at info@gresb.com, and the team will get back to you as soon as possible, as this is how we do. So without further ado, let's get it started with a bit of background on strategic direction. So we wanted to start with a kind of a sharing with you some of those, actually this slide that represents 7 drivers. These are the drivers that generally the GRESB Foundation, again, as the body responsible for maintaining and developing the GRESB standards, kind of keeps in mind at all times when thinking about how to evolve the GRESB standards and how to ensure that it remains relevant for the future. And you will know that one of the drivers here is reward operational performance. And this driver very much reflects the evolving expectation from the investor community around around the importance of the underlying operational performance of reporting portfolios to GRESB. So historically, GRESB has been assessing a variety of topics, and there is definitely an increasing focus on the actual measured operational performance of real estate portfolios participating in GRESB. So this is something that is definitely defining the direction of travel, and that's something that the GRESB Foundation and by extension the GRESB team is spending a lot of time thinking about. Now, if you think about rewarding operational performance, of course you can think about, well, the concept of performance applies to a variety of topics, right? That's why this second table on the right of this slide also shows you actually where do we even start. And that's a kind of a priority. That's something that the GRESB Foundation has been working on for a few years now, simply showing where is it that most of the effort are put as of today. And as you can see, the energy efficiency or energy consumption as the topic is the number one topic, so the highest topic on the list. So that's why, in terms of priority and strategic importance of energy performance within the standard, is essentially among the highest there is. So really the motivation came from, as I just mentioned, the need for the standard to transition towards a performance-based scoring as really the direction of travel, setting the tone for the future direction of the standard. For the ones that are familiar, for the ones of you who are mostly familiar with the GRESB real estate standard today, historically the GRESB standard has been incentivizing and rewarding the concept of like for like, so the concept of year-on-year improvement on energy consumption through reduction of energy consumption. But it is really clear that the concept of a like for like change is showing limitation, especially when an asset has already reached a level of energy efficiency that is considered high enough. In other words, there is a certain point in time whereby after which an asset is no longer expected to demonstrate year-on-year improvement, and as a result should be rewarded with full credit in GRESB on the basis that its energy efficiency is high enough. And this is really what triggered the development work for the standards, and ultimately a lot of work leveraging the ASHRAE 100 standard. The way the GRESB Foundation, through the Real Estate Standing Committee within the GRESB Foundation, has been designing the scoring approach for energy efficiency is by actually looking at what area in the GRESB standard is right now rewarding energy performance. And this area today is the energy like-for-like change. And so the idea here is actually not to replace nor to remove anything. It's actually to maintain the energy like-for-like change scoring methodology. So the blue scenario on the visual on the right-hand side, and catering for a new scoring scenario, a scenario where an asset energy use intensity would have crossed a threshold below which the asset is considered highly energy efficient, and for which the asset is no longer required to demonstrate year-on-year improvement, and as a result should receive full credit into the GRESB standard. This is what the visual is meant to be representing here on the right. So an asset is essentially going down the path of increasing its energy efficiency or reducing its energy use intensity, and as soon as it crosses the threshold, which is the vertical bar, it receives the reward in the GRESB scoring methodology by demonstrating that it is highly efficient. Now, the key question here is how do we define the threshold, which is obviously the key topic of today's webinar. I'm going to end with one simple example, just to make sure that everyone is clear. This is an example of an asset that is already very highly efficient, or in other words, its energy use intensity is very low. In this case, the asset would essentially benefit from the credit in GRESB on the basis that it is highly efficient. Scenario 2, even asset is not yet highly efficient, however, is able to demonstrate year-on-year improvement in its energy consumption. It is also a scenario that is catered by the GRESB scoring methodology, and as a result, this asset can expect to receive reward and credit within the GRESB methodology. Which means that that leaves us with the third scenario, which is when an asset is not already highly efficient and at the same time is not demonstrating year-on-year improvement. That is a scenario whereby the asset is no longer recognized or rewarded in the GRESB methodology. In other words, the GRESB Foundation is really working towards incentivizing two types of behaviors in the wider industry. One, the ownership or the management of highly energy efficient assets, or the improvement year on year on the energy performance of an asset over time. These are the two key behaviors that the foundation aims to incentivize through this revised methodology in 2025. I'm going to now hand over to Parag for a bit more insight into what all of that means, both at a technical and practical level. Parag, over to you.
Okay, thank you, Charles. So yeah, I'm going to go over sort of the technical context and the concept and the implementation of a threshold for defining what constitutes what is an highly energy efficient asset. So, before I start this discussion, I really wanted to emphasize this one quote that I love from one of the researchers we've often read is when we're going to have this entire conversation about buildings as systems and systems within buildings. But at the end of the day, at the foundation, we do realize that it's energy is used by the people in the buildings, right? So let's just to put sort of this is a human problem, and that we need human solutions and not purely technical ones, which is why you'll see me sort of, talk a little bit about the nuances of setting this threshold as we go into the presentation. Also, apologies, I do have a cold, so if I have to stop and sneeze in the middle, that might happen. Also, we're looking at energy efficiency as a part of a whole suite of tools that a manager has at their disposal. Energy efficiency is an incredibly powerful tool. We've known that for a long time. We realize it's important in resilience, in energy security, in decarbonization or net zero, as well as strengthening the grid. Energy efficiency is a key lever that a building manager can pull themselves without waiting for the grid to do anything, without waiting for anybody to do anything, just to make sure that their building performs as expected under a wide variety of conditions. So keeping that in mind, we first actually went around and sort of looked at standards and regulations and how they are dealing with energy efficiency around the world. And it's no surprise to most of the audience here that major economies are looking at energy performance requirements for both new and existing buildings, right? Whether that's through standards or policies or mandates. Um, the first generation of energy performance requirements often were asset ratings. In other words, you were incentivized to install highly efficient systems, highly efficient windows, insulation, all good things, and they're a good start. But sometimes these can lead to some confusing and mixed outcomes because improving an asset doesn't necessarily mean improving the operational energy of that asset, because operation is a different set of different ballgame. And then the evolution of that, of course, has been that many ratings and standards now require both asset and operational improvement. So in the world of ASHRAE, we had ASHRAE 90.1, which is asset improvement, asset ratings. And then we moved to now complemented that with ASHRAE 100, which is operational ratings. And Jamie will talk a little bit more about ASHRAE 100 and how that's relevant here. As Charles mentioned, we, in the foundation, this is the first time that we're really looking at the concept of what is what high operational energy performance. Those of you that are familiar with the standard know that we have rewarded data coverage for a very long time. Data coverage has a lot of importance, and that's been a good thing so far because we've incentivized the collection of data and transparency. As we move into the era of performance, right, we already have this like-for-like change score. So this was a perfect place to slot in a new type of sort of incentive to incentivize behavior, driven largely by the need to recognize high performers. If you've incentivized like-for-like change over a few years, you expect some people have followed that, whether due to GRESB or due to other factors. And so when they've reached this highly efficient stage, you can't stop giving them points, right? That feels unfair. So we're looking at this mandate from the GRESB Foundation is to reward high operational energy performance. In other words, low energy intensity. So if you're thinking of those curves, those cumulative distribution functions are plotted there for US residential, UK office, year on year. What we're looking at is the left-hand side of that curve. And when you think about this, about setting a threshold like this, the first question that we faced was, is this, should this be absolute or should this be relative, right? And this is usually not an easy choice, because if we stay within the GRESB system, there are some advantages to that and make it relative to the GRESB data. If we go outside and look for a external factor, there are some other advantages and disadvantages, and I'm going to go through them, not exactly in one-to-one order, but I'll go through them one by one, right? So if you choose an absolute target, it's a predictable target. We can publish it beforehand, as we have done this year, and you know exactly what the target's going to be, what you're going to be judged against. So you know whether you're going to get that point or not, right? Relative, and this target can be aspirational. Hang on, like I said, I didn't manage to get the two the counterpoints exactly lined up, but an absolute target can also be aspirational by design. In this case, we've chosen a target that's aspirational, but it's still feasible with current technology. So this is not, absolute moonshots. This is stretch goals. Whereas a relative target is aspirational by design, right? So you could say that, oh, use a low enough percentile, and that's aspirational. But of course, if you use percentiles, then the data from every year will increase, will cause some noise in how you decide that percentile. Um, and the percent of assets is going to be predictable, but not whether a single asset, will make the threshold or not, will make the cut or not. And that, makes it a little bit of a black box. Sorry, my clicker is a bit slow as well. There is the advantage of absolute thresholds, of course, especially the kind we've chosen here, which is ASHRAE 100, which is based on climate zone and building type, is that when we go to a new location, we don't necessarily need new data. Whereas for relatives, we do need new data, right? And, the number of assets or percentage of assets below the threshold is competitive, and it's not predictable. That maybe in some cases is not a great outcome, because we would like to know how much of the industry is about to comply. But it's one of the downsides against the rest of the fact that, when you set an absolute target, you're really being quite transparent. And of course, as I said, in the relative targets, there is a risk of bias and noise depending on what kind of data comes into the GRESB system in the first place. So just wanted to talk a little bit about and set up Jamie for talking about the ASHRAE standard itself. Speaking in general for how ASHRAE standards come about, there are dozens of standards, right? And the one we're talking about is ASHRAE 100, which sets EUI targets, so energy use intensity targets, using building types and climate zones. The climate zones, right, and the building types, together they form this idea of a technically feasible but aspirational outcome, right? And Jamie will talk a little bit more about how that was set to be aspirational but still technically feasible. It's unrelated to the grid decarbonization trajectory, which means that it is not tied to a specific political or geographical or jurisdictional context. They are updated roughly every 4 years. And, they are also used by comparable frameworks like LEED, for example, right? So LEED V5 does reference ASHRAE 100 as well. The reason we picked climate zones is also something. I mean, this is something new to GRESB, but I mean, of course, climate zones have been around for a long time. The concept has been around literally for hundreds of years. But anytime you talk about climate zones, the advantage is, of course, you're now being global, right? Because climate zones are a global concept. So they're not specific to a country. You can make specific climate zones to a country, but the ASHRAE ones are global. They are a compromise between being precise and representative on the one hand and being simple and utilitarian on the other hand. So we need them to be simple enough to be able to be used in codes. So you can't have a list of 500 climate zones, but you need them to be also precise enough that there's actually a differentiation between areas with different kinds of climates. It is a well-known, sort of well-understood fact that EUI and electric and combustion fraction generally varies by climate zone, so they're a very strong determinant. They're widely used in ASHRAE standards and international energy codes. And just wanted to show you what the climate zones actually look like, for those of you that haven't explored that already. They have two components. There's the thermal zone, which goes from 0 to 8, 0 being extremely hot. So this is the right-hand side where there's a lot of cooling requirement, in other words, all the way to 8, which is subarctic or Arctic, which has almost no cooling requirement, but has a very high heating requirement. And then, of course, everything in between. It's supplemented with a moisture zone. So really, the only thing you need to do to calculate these zones is temperature and precipitation. And where precipitation is not available, there are some compromises listed in the standard. So you can calculate basically for the entire world, right? And we've done that by buying the ASHRAE weather data set and then locating the nearest weather station to every asset that's submitted to us, and then be able to tell you exactly what your climate zone and the ASHRAE 100 threshold is. The fact that there are numerical calculations is really important here because it means there's no judgment call required from us to tell you which climate zone you're in. I think I'm going to just sort of finish a little bit with the outlook on where we think this might be going. As Charles said, the assessment now rewards, and actually always intended to, and now does so explicitly, rewards the best of two outcomes, right? Either you show good year-on-year improvement, which is indicative of investment, it's indicative of brown to green strategies, it's about continuous improvement, or you show highly efficient operation, so it's optimized, it's already green, and you're looking at continuous maintenance. Both of these are desirable behaviors. The other thing I want to talk about is that measuring energy efficiency is an important aspect of net zero readiness, which is a strategic area by the foundation. It allows you to clearly demonstrate impact, and it's a fairly straightforward assessment of a building because it's literally just a simple calculation. And my final point, and apologies I've run over a little bit, is energy efficiency is a key tool to creating a net zero ready building. We're going to work a little bit more on this in GRESB on how to place energy efficiency in a decarbonization theme and how to harmonize with other performance metrics like GHG, renewables, and water. And with that, I will hand over to Jamie. And thank you, everybody, for listening.
All right. Thanks, Parag. So you all had such lovely formatted slides. Mine aren't too bad, but apologies if some of them have a lot of text on them. Don't fall asleep, everyone. Yeah, I'm going to talk a little bit about ASHRAE 100, a little bit more about myself that I was thinking about while you were going through your presentations so before I started working at PNNL, I was a commercial energy efficiency consultant, did a lot of energy audits, helped out with portfolios that were submitting to GRESB. And so anyway, it's interesting to be kind of hanging out with the other side of the crowd here, but also this idea of rewarding, like increasing energy efficiency versus just attaining a high level of energy efficiency is very, very pertinent to what I did when I was a consultant, and was the reason that I got excited about ASHRAE 100 back when I joined. Okay, first off, though, I want to, for those that aren't familiar with ASHRAE, I wanted to give a little bit of background. ASHRAE is an international society of heating, refrigeration, air conditioning professionals. It was initially created in the US. The A stood for American. However, ASHRAE doesn't go by their full spelled out acronym anymore. They just go by ASHRAE because over the years, their membership expanded to be highly international. There's a lot of local chapters and a lot of influence across the globe. And so yeah, they just, the A stands for, I don't know, all people, I don't know. But yeah, a few roles of ASHRAE. They do different kind of networking and professional development activities. I was very involved with the local chapter back when I lived in Atlanta, Georgia, and but as well, and the thing that's most relevant to us today is that they publish and maintain a bunch of standards on HVAC and R. Or related to that. Many people in the US are very familiar with ASHRAE 90.1 because that defines a lot of new building codes for commercial buildings. But yeah, like Parag said, there's dozens of different standards of different, getting into really niche topics about ventilation, about how to measure, I don't know, how to calculate emissions factor, how to, et cetera. So, and while I'm not an expert in the full consensus-based or ANSI processes, essentially all of the most ASHRAE standards committees are following ANSI processes, which means they're consensus-based. They require a broad range of individuals to participate from different parts of the industry, and are subject to all sorts of kind of publishing, public review type processes to make sure that what's coming out is a reasonable standard representative of current industry. All right. So, and I guess then funneling down a little bit into Standard 100 specifically. So this is one ASHRAE standard. I currently serve as the vice chair of that standard with a bunch of other awesome engineers from all different walks of life. And but yeah, I'm going to give you my best rendition of the history of 100, which, so back in 1995, Standard 100 was first established, really as a call for the importance of existing building energy efficiency, essentially. Yes, you can define what new construction should look like, and that is extremely important in setting buildings up for success down the road. But once the building, like a building only uses energy when it's existing, like when it's in operation. And so that kind of was brought into focus by Standard 100. In 2015 and the years before, Standard 100 was revived again and expanded because there was a increased need for, well, how do you go about doing the energy efficiency improvements in the first place? Not this is completely agnostic to any energy efficient technology, but just how do we look at energy efficient performance? How do we prove it? And then if a building is not established as highly efficient, then what processes do you go through? You conduct an energy audit, you implement energy efficiency measures, and then you verify that you've achieved those savings. One of the things I'll point out here is in 2015, there was I hadn't joined the committee yet, so this is me transferring what past members shared, but the committee really debated about whether or not to provide energy use intensity targets, so specific EUI values, to establish that performance. And the reason being, it's really hard. Like Parag knows, it's really hard to set some performance threshold. But a performance threshold that's not perfect, because there's no such thing, is leaps and bounds better than no performance threshold at all. It's so important to set that bar of performance so that people know people have a target, people have somewhere to go. So these targets in 2015 were developed by Terry Sharp, who was working at Oak Ridge National Laboratory, another U.S. Department of Energy lab. And yeah, the 2015 version was updated over time. Just recently, last year, we added emission performance requirements as well, which don't get pulled into, like, isn't relevant here because you all have different methods of addressing decarbonization. But and also, as of now, we have 2 U.S. states that have adopted Standard 100 for their purposes in improving building energy efficiency. And I included this diagram here. I just wanted to show you all, this is the full process of 100, which honestly includes many of the aspects that GRESB hosts within it. You've got to have plans for energy management. You have to conduct regular assessments and look at your performance over time. Now what we've done is we have these specific energy targets within 100 that's now being leveraged by GRESB, and these are what set kind of a concrete a concrete goal for buildings and allow you to differentiate yourself as kind of already achieving high efficiency. Okay, thus the energy use intensity targets, you know, these set a minimum energy performance level. Of course, if you are achieving that already, then awesome. You're already there. You're already relatively efficient, and you're good to go. And within 100, we have EUI targets available for 55 different building types, 16 different climate zones that include those climate zones 0 through 8, and with the different moisture levels that Parag talked about. All right, now just avert your eyes if you don't want to see too much text. Sorry, everyone. But I wanted to give you a little bit of an overview. So these targets were developed again by Terry Sharp at Oak Ridge National Laboratory back in 2015 and have also been updated to include more recent data. So right now the data comes from the United States, a large energy survey and residential survey. These data sets are a nationally representative sample. They collect a very large amount of building characteristics as well as building energy consumption data. It's the premier data set in the US to characterize building energy use. However, also one of the barriers I guess we've had is that while it's a great data set, it's still limited, and in terms of differentiating by climate zone, the US doesn't have all climate zones, and not all climate zones are heavily represented within the data set. So back in 2015, when this was initially created, we modeled different prototype buildings, so did some energy modeling to come up with what's the relative EUI that would be in different climate zones. And initially, when we did this, when the analysis was done back in 2010, 2011 timeframe, this was only for US and Canadian climate zones. However, in 2024, the standard was updated to include all climate zones, so those 0 through 8. So it covers the entire globe. And then the last bit is just in terms of getting as close as we can to an indication of technical feasibility. These targets were initially based on the 25th percentile of the US building stock, so that essentially the lowest 25% EUIs are in compliance or meeting these targets, but 75% of buildings would need to take some sort of action. While this is a great metric, it in some ways doesn't really matter when you think about things globally or when you think about things over time, because this was based on historic data as it has to, because we don't have our data instantaneously. But this sets, at least in the US, it shows that there's technology feasible to achieve those EUIs in a decent number of buildings. All right, I think that's everything I meant to cover. Thanks so much for your time, everyone. We are going to switch to some questions, some commonly asked questions that folks have received about these new targets, as well as an open Q&A from the group. Thank you.
Thank you very much, Jamie. I can take over from now. What we've done is obviously this whole the announcement of the alignment between GRESB and ASHRAE 100 was published at the end of last year, November 2024, and since then, a lot of GRESB members have actually raised a lot of questions around. We'd like to know more technical details. We'd like to hear more about how it applies in certain regions, etc., etc. So what we've done since then is we've actually gathered some of the most relevant and recurring questions from our members asked in the past, and we made a short list of those questions to as a start of to initiate this conversation. But of course, if you do have other questions, feel free to use the chat as mentioned earlier. I'm going to start with you, Parag. Um, I suspect the audience would love to hear a little bit more about how the coverage of the GRESB dataset itself compares to the coverage of ASHRAE 100, especially in terms of building types. I'm thinking about is there any analysis that we did to actually understand to what extent the 200,000 assets reporting to GRESB every year are actually covered by an ASHRAE 100 value. Is there anything that you want to share with us on this a little bit more, please?
Yeah, sure. I don't know if you caught in Jamie's presentation, there are 55 building types covered by the ASHRAE 100 standard. GRESB also has an extensive number. I'm forgetting the exact number now, but close to that. As you can imagine, there's not a perfect overlap, and often even when the building type is the same, we still use different words to mean the same thing. So, along with some colleagues in the product side and the real estate colleagues, we map the different ASHRAE types to the buildings in GRESB, to the GRESB subtypes. Um, and we basically achieved really, really good alignment. About 95% of assets submitted in 2024 and 2023 would map to an ASHRAE subtype, right? There are some exemptions, like other parking indoors, industrial manufacturing is a big one, and self-storage is a big one. Now, that doesn't mean we abandoned these building subtypes. It's just that we didn't have an exact equivalent in ASHRAE. So we will look at alternatives down the line, including potentially working with the 100 committee and using their methodology for setting standards once we have enough data to set a standard for these missing types, right? So I think one aspect that we haven't spoken about here is not only is the 100 standard set EUI targets that you can just take off the shelf as we've done now, it also has methodologies to help you modify and update and customize those standards for different contexts, which in the case of GRESB was not strictly necessary because we are global. But if there are specific sectors that feel ignored, we can certainly go after that. In terms of numbers, Charles, I had to look this up again because I keep forgetting. There are only 9 subtypes that from the GRESB side which are not mapped, and some of these are really tiny. Like I said, other. Right?
I mean, what is the solution to solve the other except incentivizing participants to better classify assets or to make sure that we expand the list to become more relevant? So, but you mentioned 95% coverage, Parag. That sounds to me like a really good match in terms of leveraging an external absolute standard into the GRESB universe, which was obviously a big open door towards considering the ASHRAE a standard into the scoring methodology. Do you want to say a few words around what the GRESB Foundation is actually thinking about in terms of bringing that 95% to 100? Is there something that is on the radar at all? Like, are we doing any thinking around making sure that we do cover those missing building types in the future?
Yeah, so in the future, certainly I will say this year we are going to work on different refinements, and I can talk a little bit about that later. But as I was sort of hinting at earlier, if we can collect a sufficiently representative data set for the missing data types, we can work with the ASHRAE 100 committee, who have expressed a lot of enthusiasm for this, actually, and I thank the committee for that, to try and use the same methodology so that we can align and create essentially GRESB specific thresholds for those ignored subtypes. What's preventing us from doing it like immediately straight off the bat is the fact that we do need a representative sample from most, if not all, the climate zones. Um, Otherwise, we have to do some simulations, which is completely feasible, but it does take a little bit more time to get. So that, we can't make a standard that just covers, I don't know, the 3 most common climate zones and ignore the others. So yeah, certainly something for the future. It'll require a little bit more thought and effort.
Thanks, Parag. That's useful. I'm staying with you for the next question, if that's okay. And I'm actually curious about how the ASHRAE 100 values compare to the actual GRESB data set. So my question would be, as part of the development of this new methodology at GRESB, was there any analysis conducted around how the current GRESB data set, so again, about 200,000 asset reporting annually, compares against the ASHRAE 100 energy use intensity values? Can you tell us a bit? Can you tell us something about how accessible it is, and how ideally ambitious those values are compared to the current building stock represented in the GRESB data set, please?
Yeah, so as you can imagine, if you're in a jurisdiction which has a fairly strict energy code already, or has had it for a long time, then you expect that market to already be ahead of ASHRAE 100, right? Somewhat surprisingly, the best performing markets, by in a market I mean in GRESB terms, that's a country and sector or a building type, still don't exceed like more than 20% of the buildings qualifying for this. So we're talking about investor grade assets, which presumably get a lot of investment. They are in markets that have a strict energy code, presumably, and have had it for a long time, or construction practices that outpace the US's, for example. And still, fewer than a quarter, about a fifth of them only make it past the threshold. So this is definitely aspirational. And then, you can get as low as 5% of buildings exceeding. So the median comes out to less than 10% of the buildings exceeding or the requirements of the UI requirements. And keeping in mind, this is retrospective analysis. So this is 2024, 2023 analysis. We hope that in 25, 26, as we start incentivizing this with points, then that will start shifting until, as Jamie said, the target is set in mind that the majority of people have to work to do something to meet it. And those technologies are available, and hopefully this incentivizes that kind of investment.
Thanks, Parag. So what I retain from your answer is about 5% on average. It sounds to me like a very small number, such that reflecting let's say the how ambitious those targets are, but at the same time that number is positive, which means that it's accessible, it's technically feasible. Whereby, of course, that's something that GRESB Foundation had to be comfortable with. Is if the number was actually close to zero, then the GRESB membership could eventually perceive it as, well, it's ambitious. It's so ambitious that it's actually not achievable, and as a result, not driving meaningful change. So it seems like a 5% on average is kind of balancing those two tension quite right.
Yeah.
Jamie, back to you with a bit of a question, like a bit of a forward-looking question, maybe. Thinking ahead, we obviously hope that we actually expect that the wider building stock will continue becoming more and more energy efficient in the future, right? That's obviously why we do what we do. And as a result, begs the question around the need to update the ASHRAE 100 values in the future. Is there something, could you tell us a bit more about how frequently and on what basis does ASHRAE intend to update those values in the future? Obviously, you want to make sure that those values ensure it continues to move the needle within the wider industry, so that requires a bit of an update. But that's not something that you can do too often, because otherwise you don't provide that kind of a stability within the industry. So would you mind elaborating a little bit on that?
Yeah, absolutely. So 100's targets have been updated once at this point since 2015, I think. So that's an average of once every 5-ish years. It depends on really what data we have available to us. So the committee is hoping to, at some point in the future, update their targets to the most recent set, to base it on the most recent set of the US Energy Survey data. So yeah, you might expect an update in the next 3 years, although I can't say for certain how that all goes, because it's part of the it's all up to the committee. There's I will add though, there's some discussion, like you mentioned, you want some, the benefit of an absolute threshold is you've got some stability associated with it. And especially for energy efficiency, theoretically, there's some kind of limit where you're not really gaining a whole lot from EUI improvements. And if everyone's achieved highly efficient operation, now we're just kind of eating away at that like exponential curve, or spiraling into that nautilus shell, and not really anyway making it more difficult. So there's some theoretical possibility that we'd set specific EUI targets and leave it at that, and say this is the standard for highly energy efficient systems. Though you could also say that as technology develops and as we develop more innovative systems for insulation, for HVAC, for water heating, etc., that number is always going to be trending downward. Now, there's a counterpoint to that, which is that some buildings, because of the way markets change, some buildings will tend to have increased energy intensity. For example, we found from updating to the last targets that I believe it was hospital energy use intensities went up compared to previously, and that I'm not an expert in hospitals, but that kind of matched the idea of like growing numbers of procedures that are available, and high tech things happening in those buildings. And so that to me makes perfect sense. But also we're getting a lot of value out of that, that energy that's being used in that hospital. So there's there's some flexibility with it as well.
Yeah.
Great.
Charles,
Parag, did you want to add anything?
Yeah, I was just gonna give
Yeah,
a
sorry.
slight that's all right, slight historical perspective on what JB just said, because I read this a lot as part of my PhD. Was what Jamie is talking about, she hinted towards the end, is this standard in the current technological paradigm, it, yeah, you expect it to tighten a little bit over time, right? And at some point, it reaches the limit of what a building, the way we perceive it now, and the services we expect of it now, right? But as buildings change, like if you go back 200 years, the expectation of a building and versus today is radically different. And now we're adding loads like electric cars, um, potentially heat pumps. So you're changing fuels, you're adding batteries, and these kinds of huge technological shifts could and of course, let's not forget solar panels that have been around for a while, but have suddenly become so cheap that everybody can get them, including myself. It changes the equation that a building has in the energy system and a role that it plays. So pure efficiency is one lever, as I said earlier. And if you've seen the decarb work we put out, it's one of the 4 or 5 levers that we're looking into. So let's just say that these values are very good for the current technological paradigm. If 10 years down the line we're having this conversation, we look back and say, wow, buildings have completely different expectations. We'll probably need to have a slightly different conversation and maybe use different metrics.
Agreed.
Yeah.
Thanks. That's very useful insight. Thanks, Parag. While you were talking, I was actually checking if there was any question on what we're talking about from the chat, and we actually have a few questions coming in. So if you don't mind, I'm going to move to the chat now. And there are actually 2 questions that came in that are somewhat related. So I'll try to give it a go and make sure that and maybe ask you, Parag or Jamie, to see if I'm in the right or not. So somebody is actually running an international non-profit active in the sustainable school sector. And the question is around, well, there is very little data for EUI for schools in the sector today. And so the person is asking if there are any data in the education, or more specifically in the school sector on ASHRAE. Is this something that I was actually looking at the standard myself while talking, but Jimmy, is this something that you want to take?
Sure. Yeah, I can speak to this a little bit. Yeah, so 100 has targets for I think it's divided into elementary school, middle school, and then high school. So there's two different data sets there. I could dig into the data a little bit and see what's the total number of schools represented behind those stats, but I would guess it's on the order of like maybe at minimum 100, maybe maximum 500, something like that. In terms of energy reporting in the US, there's quite a bit of school data available. I can't comment about internationally how that's available, but yeah, we do have those targets, and yeah, so you'll be able to compare those schools to those. And in fact, if you want to get real deep into the weeds on it, you can go ahead and download the source data, the Commercial Building Energy Consumption Survey from the US, and take a look at filter it by the schools. Anyway, it's depends on how nerdy you want to get, I suppose.
Thank you, Jimmy. That's useful, and I think the second part of that person's question is also about what's the kind of a channel to access those values, which is very much linked to the second question, which was I was talking about earlier. Somebody else is asking, how do we actually access those values? This is something that we have to purchase online. Is this available publicly? So maybe to reiterate, the ASHRAE 100 standard is available for consultation purposes only via the website for free, for consultation purposes only. And if you're interested in the actual PDF, that's available at a very reasonable fee. So this is something that that is available, and we can follow up with the direct link. That's something that we've shared with the wider GRESB membership in the past. But those values are available. And if you are a GRESB participant member, also remember that we have done a lot of work with ASHRAE to make sure that we can provide directly to GRESB participants the value, the relevant EUI values that are relevant to their portfolio with which they participate in GRESB. So if you are a GRESB participant today, you simply log into the GRESB asset portal. You will see your portfolio composition as you see every year, and there'll be a bunch of new columns this year about these are your ASHRAE 100 values relevant to all your building type and climate zones that we have done the mapping in the background that is already done for GRESB participants. So there's various ways you can access those values, a direct way through the GRESB portal if you're a GRESB member, and an indirect way through the ASHRAE's website if you're interested in the full document. Anything that I may have wrongly interpreted, Jamie, in my explanation?
Nope, sounds great.
Awesome. We have a couple minutes left. Maybe there is one question that we often get from whether it's GRESB investor members or GRESB participant members around is this the end of the story in terms of developing the standard, or is it just the beginning? And actually, I want to shed light a little bit into what the GRESB Foundation has in mind when it comes to about next steps. So obviously today we are introducing a more absolute way to score energy performance in the standard, right? But obviously, the next step that we can expect from the future work on the GRESB standard is actually to go down the list of relevant ESG topics with through which we want to do that. You remember this slide with carbon, waste, water, indoor environmental quality, resilience, biodiversity. So obviously today we're addressing energy efficiency because that's the highest of the list, but we can definitely expect to apply a similar approach to other topics in the future. That's the first thing I want to say. The second thing I want to say is the very logic of introducing absolute value for scoring purposes is definitely the direction that the GRESB Foundation is taking. Moving away from relative only to more relying on absolute threshold is something that we expect not only applies to energy, but also other topics in the future. And finally, to make sure that it has the impact that the GRESB Foundation is seeking to have into the wider industry, we also expect to have an increasing number of points allocated to those performance area in the standard in the future. Today, we've mostly talking about 2.5 points allocated to energy efficiency, but we can expect that weight, that scoring weight, to also increase in the future to better reflect the standards transition towards being performance-based. With that, I think that's it in terms of question. We have 2 minutes left. Is there any last comment, Jamie or Parag, that you want to add before I close?
No, just so glad to be here. It's great to be involved. Thanks, everyone.
Yeah, likewise, nothing to add. Thank you.
Great. So thank you very much, everyone, for attending this webinar. As I mentioned earlier, we will follow up after this webinar to all participants with a direct link to the recording. If you want to rewatch or share that internally within your organization, that's absolutely fine. And if you do have questions that you have not had the opportunity to raise, feel free to reach out to us via info@gresb.com. In the meantime, take good care of yourself, and good luck with this year's reporting for the participants among yourself. Thank you.
Right.
Thank you.